Hello and welcome to A-Level Revision Sheet 6, where we're going to briefly look at sequences. So using our knowledge of sequences, we've got arithmetic, geometric and then some general properties as well. We're going to start with the general properties, just a little recap. So increasing sequences are ones where the terms are always increasing, i.e. u of n plus 1 is greater than u of n for all n, i.e. so this means that term 4, for instance, is bigger than term 3, term 5 is bigger than term 4, and so on. For instance, the example given there. Similarly, we can define a sequence to be strictly decreasing if subsequent terms are less than the previous term for all possible terms. And we also have a definition for periodicity. So a sequence is periodic if the terms repeat in a cycle. The order or the period of the sequence is how often it repeats. For instance, the sequence given there is periodic and has order 3 because the repeating block is of length 3. Using the fact that the ellipses just mean that the sequence goes on forever, so the next two terms will be 3, 0, 2, 3, 0, etc. We have to know two types, really, of main forms of sequences for the course. The first one is arithmetic sequences, and you've known these for a long time because they are just the linear sequences that you would have studied at GCSE. So an arithmetic sequence is of this form. It's got a first term A and a common difference D. So every time to get the next term you add D to the previous term, i.e. they're all going up by D. Where I use the fact that if D is negative, it's going up, but the numbers are decreasing, if that makes sense. So we've got our formula for the nth term, and then we also have these two formulae for the sum of the first n terms, and they are given in the formula book. And here L is the last term in the sequence of n terms. And then we have geometric sequences. So again, you will have first come across these at GCSE, and this is a sequence of the form A, AR squared, and so on. I.e. each term is obtained from the previous term by multiplying by this value R, which we call the common ratio. So again, we use A to be the first term, but now R is the common ratio. We have our nth term formula that's worth remembering. And then in the formula book, we also have the sum of the first n terms, the sum of the infinite number of terms, or sum to infinity. And this only holds if the modulus of R is less than 1. Okay, so let's do a couple of examples. So the first one, I've got this sequence, and I want to determine whether it's an increasing sequence. Well, if increasing, then u of n plus 1 minus u of n will be greater than 0 for all n in the naturals. So if I start with this, u of n plus 1 minus u of n, well, this is n plus 1 over n plus 2 minus n over n plus 1. We can put them over a common denominator, and we end up with n plus 1 times n plus 1 minus n times n plus 2 all over n plus 2 n plus 1. Expanding our brackets, we've got n squared plus 2n plus 1 minus n squared plus 2n over n plus 2 n plus 1, which is 1 over n plus 2 times n plus 1, which is always bigger than 0 for all n in the naturals. Hence, the sequence un is increasing. Example 2 then. So the fourth term of an arithmetic sequence is 17 and the ninth term is 32. Well, let's use that information first of all. Well, let's just write it down. So using our nth term formula, u4 is 17, but u4 is a plus 3d. u9 then is 32, but using the nth term formula, that's a plus 8d. So we've got two equations. A plus 3d equals 17, and a plus 8d equals 32. Now, solving these, we obtain a equals 8 and d equals 3. So the first term of our sequence is 8 and d equals 3. We're asked to find the first 50 terms. So using the formula in the formula book, S50 is 50 over 2 times by 2 times 8 plus 49 times 3, which is 4,075. So this is using the formula Sn is n over 2 times 2a plus n minus 1d, where here we've got a being 8, d being 3, and n being 50. Okay, let's move on to our final example. So our final example is about a geometric series now, and we know that the sum of the first 10 terms is 3069 over 512, and the sum to infinity of the same series is 6. Okay, so now, this time, we're going to use the fact that in the formula book we've got our Sn formula. Well, that's a times 1 minus r to the n over 1 minus r. And here the sum to infinity is 6. So we also have the formula S infinity, or sum to infinity, is a over 1 minus r. So we're going to use those. So using the formulae, then we've got a times 1 minus, we know it's n is 10, so r to the power 10 over 1 minus r, and that is equal to 3069 over 512, and that's my equation 1. And then we've also got a over 1 minus r is equal to 6. And from that we can rearrange to say that 1 minus r is equal to a over 6, and that's equation 2. So we're going to substitute 2 into 1. So from 1 we've got a times 1 minus r to the 10 all over a over 6, and that's going to equal 3069 over 512. So we can rearrange this now to say that 3069 over 512 is 6 times 1 minus r to the 10. So 1 minus r to the 10 is equal to 3069 over 512 times 6, which is 3072. So rearranging this, r to the 10 then is 1 minus this, 3069, 3072. So r to the 10 is equal to 1 over 1024, which implies that r equals a half. I'm going to have to go over here. I think I've got another slide. So if r equals a half, then a equals 6 times 1 minus a half, which is equal to 3. And using this, we can then find the sum of the first 5 terms being 3 times 1 minus a half to the power 5 over 1 minus a half, which is 93 over 16. Okay, so there's 3 examples. We've got some questions for you to do on the sheet and then some exam questions as well. Give them a go and let me know how you find them. Good luck.